In today's video, we're going to honor a special request to use multiple tools to make a production run of parts. Do a whole bunch of parts and they're all the same. And we're going to use we're going to use a cutoff tool. We're going to use a end mill. We're going to use a center drill, and we're going to use this one twice. We're going to call it tool number 4 as the stop so we can locate our part, and tool number 5 so we could chamfer the nose of the part. And we're not going to use the boring bar today, but we are going to use 5 tools: 1, 2, 3, 4, and 5. And it should be a lot of fun. Now, about chamfers, let's go ahead and go over a basic kind of instructions on how to put chamfers on a CNC. Alright, let's go over a kind of a beginner's course in chamfering with CNC lathe. In any right triangle, meaning that this is 90 degrees. As long as side, for instance, A and B are the same, we always have a 45 degree angle here. So we've got 90, we've got 45, and we have 45. Just like that. So on that principle, here let's make a big 750 right here. Okay. This is what we have in our 5C right now. And we want to put a chamfer right here. And let's say we want to put a 50 thousandths chamfer. So we've got 50 thousandths on this side, and we've got 50 thousandths on this side, and that's going to cut it off right at 45 degrees when we run our cutter down here. So we have to set this up. So we have to have a starting place. Now remember, we're in the diameter mode right here. So whatever we add here or subtract here, we have to add and subtract on the other side as well. So this is actually 100 on the X. So I'm going to go down 100 thousandths from my 750, and that's going to be X equals 650, and my Z is going to be right here, and that's going to be Z0. Z equals 0. Okay, now that's how we're going to start, and then where we're going to finish up, it's going to be X 750 Z minus 50 thousandths. That'll all be on one line with a feed rate. So the tool's starting to come, and we'll cut it right off, and that'll be the end of that. Now the only problem with this is that there's not much room in here, and you should really start out here and end out here, so the whole thing is nice and clean, that you don't mess up your face. So how are we going to do that? Well, remember, all the way back up here, as long as the sides are equal, it's always going to be the same. So here's what I mean about that. Now here it's 50 thousandths down, and we're going to go, say, 100 thousandths out. And if we're going to do that, we've got to go 100 thousandths down. And that's going to make this line connect right there. And we're going to do the same on this side. The same on this side. If we were to go 100 thousandths up, and we're going to go 100 thousandths down, that line is going to continue just like so. But all we need to know is, what are these numbers? Now, we already know that this is 0.1, this is 100 thousandths, and this is 0.1, this is 100 thousandths. So we have a total of 150 thousandths. Now that, being the diameter, means it's times 2, which means it's 300 thousandths. And we're going to take 300 thousandths away from the 750, which gives us X 450 thousandths. And the Z is going to be 0.100 thousandths out right here. We're 100 thousandths out. That's where we're going to start from. Now where we're going to finish is, obviously we went up 100 thousandths here, and we went over 100 thousandths here. So what are we a total of? We're a total of, the Z is 150 down and we're 100 thousandths up, but this is diameter, so it's times 2, so it's 200 thousandths added to this, which gives us, we're going to X 0.950, and we're going to Z minus 150 thousandths, and we'll just say it's going to be a feed rate of 0.1. There you go. Now let's get back to the machine. Here we have the program that's going to be run. Here we have our standard header. Now you can look all of these up in the G code, but you'll see that this is just a standard header. And this G52 right here, so I can move the whole thing down or back, the entire Z. That means I can run the program without hitting the part, so forth. That's all that's for. So here's setting the part, and now here we have the chamfer. Remember what I told you. Now I've got the spindle running, and I'm starting out at 450 and Z 0.1, 100 thousandths. Now here, I'm moving there pretty rapidly just to get there. But the actual cut itself, X 950 thousandths, Z minus 150 thousandths at a feed rate 10 thousandths per revolution. The center drill right here is pretty standard. We're just going a single plunge. And the end mill, I thought I'd show you this. The end mill, as we set this up, we have a G83, meaning I'm pecking this down. And I've set it to go down 360 thousandths at 60 thousandths per peck. That's 6 of them, and at 10 thousandths per revolution on the feed rate. And here we have our cutoff tool. And this is very interesting because when you're figuring all of this in for doing parts, you have to figure in the width of the cutter. And the width of the cutter, of course, in this case is 65 thousandths. So you have to figure all of that in as you're getting around. So let's go back to the machine. The first thing we're going to do is we're going to set the part depth. Just like so. Now we want to push this forward as we're tightening up the collet, because the collet will tend to draw it back. So you just keep pushing it forward a little bit and it'll stay there. There we go. Now the first thing that's going to happen, of course, is we're going to put the chamfer, then center drill, and then we're going to use the end mill, and then we're going to cut it off. There's the chamfer, center drill, and there it is. You can see it's got that little chamfer right there, just like we programmed into it. And this should be .250 thousandths thick. And it is, it's about a thousandth over, about 251. Let's make another one. We'll set the part. Move it up. Cycle start. Let's catch this one. Almost. And there we have a part. Just like the first one. Now I got two. We're going to make one more. Push it forward, lock, cycle start. I caught that one. There we go. Production parts.